Hello, this is a quick little video to help you on one of the homework questions that you have from section 3.1. So your instructions read, solve the system of equations graphically. Then classify the system as consistent or inconsistent and the equations as dependent or independent. All right, so I'll talk about that first little part, solving the system of equations graphically. So to solve a system of equations, we want to see where they cross, where they meet. To do this graphically, I want to graph each one separately and see if they cross anywhere, if at all. So before we begin, let's talk about all the different ways you can graph. And you have so many tools in your toolbox, your mathematical toolbox. So first is you can do a chart. You can create an X, Y chart and pick points for X and plug them in and your answer will be Y. Second, you can use your X and Y intercepts. And third is you can use the y equals mx plus b and graph your y-intercept followed by your slope. Meaning use your slope to plot the next point. So after you plot your y-intercept, you use your rise over your run to graph the next. And it's just a brief list of what we do for each one. Okay, to begin, let's take our equations. Let's go ahead and solve for y. And we do this so we get it as y equals mx plus b. Because I'm going to try to graph using that third one from our list. And I'm just going to number them so that I know what I'm talking about in the future. So the first one we have is 3x minus y equals 6. Let me go ahead and solve for y. Let's get y by itself. So let's move 3x minus 3x minus 3x. So that we're left with negative y is equal to negative 3x. Positive 6, so plus 6. Now I get y by itself. To get rid of that negative, let's divide by negative 1. And what we do to one side, we do to the other. So we're left with positive y is equal to negative 3 divided by negative 1. That's positive 3x. And 6 divided by negative 1, that's negative 6. Okay, that's my first one. My second, we have 3x plus 4y is equal to negative 9. I want to get y by itself, so let's move that 3x. So minus 3x on both sides. And we're left with 4y is equal to negative 3x minus 9. Last piece, I want to get 4 by itself. Y by itself. So we divide by 4. So 4 can divide to make 1. And we are left with y is equal to negative 3 divided by 4x and negative 9 divided by 4. Okie dokie. So here we have our graphs that are going to attempt to graph. The first one isn't so bad. We can go ahead and graph that one pretty quick. So I'm going to use my y-intercept and my slope. I have a y-intercept of negative 6. I'm going to plot that point, which is the point 0, comma, negative 6. And then I'm going to use my slope. My slope is 3, so I can write it as 3 over 1. And I know that tells me where I rise over your run. Because it's a positive, I'm going to go up 3. Because the positive, I'm going to go to the right 3. I'm sorry, right 1. So I'm going to plot this point of negative 6 and then go up 3, right 1. So I have my graph here. I have negative 6. So I have negative 8, negative 6 right here. Then I go up 3 over 1. So then I go 1, 2, 3. Then to the right 1. I'm here. Okay, that's all I need to graph my line. All right, so your graph looks something that's a lot better than this. right? And it's one continuous line. Okay, the next one is kind of where the hiccup happens or the trouble happens. So for the next one, when I try to graph it using my y-intercept and my slope, my y-intercept is not a whole number. And this is where I got the emails because my MATLAB doesn't let you graph fractions on the coordinate plane. So this is one, the disadvantage of trying to solve a system graphically, but it's also a disadvantage with this technology we're using. So we're going to use something else to go around this. So we see that our y-intercept is not a whole number, and my slope doesn't matter, because even if it's not a whole number, we just use the rise over run, right? So that being a fraction is not a problem. This is where we have a problem. So there's different ways you can combat this. One is you can go ahead and sit there and make a chart and wait until you have a number that's a whole number. So you can test all these numbers between maybe, for example, -5 to 5, or you see that your range is from -20 to 20. So you can plug in all the numbers between 20s, between -20 and 20, but that's a lot of work. So how can we combat this without having to sit there and wait until we get a whole number and another whole number so that we can plot it into MyMathLab? So I sat there wondering what's the most convenient way to do this for us that would not be too time consuming. So let's use technology. What we're going to do is we're going to go to Google and type in Desmos Graphing Calculator. And you feel free to use this anytime. So what Desmos does, you pick your first option, Graphing Calculator Desmos. What Desmos does is a website where honestly you can do just about anything math. Here it lets us graph. So let's go ahead and take our two graphs. The first one was -6 and y equals 3x minus 6, right? So we have 3x minus, oh, not times, go back, minus 6. Let me just check, because I'm doing it from memory. Yeah, 3x minus 6. Then I have -3 over 4x minus 9 over 4. -3 over 4, and then I'm going to use this bottom ABC to get my variable x. And you see how it puts in the denominator? X is on the denominator, so I need to step out of that fraction. So I just clicked on it. If you were using your keyboard, you would just use a right arrow at the bottom. Now I can put my x, and it was -3x minus 9 over 4. Minus 9 over 4. And then I go back to 1, 2, 3. So minus 9 divided by 4. Okay, so that first one wasn't a problem to graph on Desmos. So I'm going to momentarily ignore that one. So I'm focusing on the second with that, with where each well, specifically where my y-intercept was not a whole number. So I want to graph it, so I want to be able to pick out whole number points. If you see here, it looks like, and we have a grid that helps us, luckily. You see here that this is precisely a whole number, right? It's -3, 0. I can't hold my pencil straight. -3, 0, there you go. And then I want to find the next whole number. And we can kind of use our grid to guide us. And if you click on a line, it tells you exactly where that point is. So if it's not a whole number, you know to ignore it. And you see that kind of about here, we have another number, right? We have -1, -3. So I'm going to graph -3, 0, and 1, -3. All right. 1, -3, 1, -3, and the other one was -3, 0. And there we have our other line. And that's all you're asked for this problem. You have to graph both of them separately, you check them, and then it says yes, and then it says, what's that point? And you can go ahead and zoom in. What is that point where they meet? And you see that that point where they meet is 1 comma negative 3 for this particular problem. Okay, I hope that helps you graphing lines where your y-intercept is not a whole number so that you can graph it onto your MyMathLab grid. Thank you for asking your questions. I hope this helps.